Hello everyone, in today's video I would like to talk about the floating point numbers or reals in the Siemens PLCs. I would like to show you an interesting fact about them. Let's have a look at the following code example. We have the x being defined as a real with the starting value of 0. Then there is a while loop. When the x is different than 1.0, it should be incremented by 0.1, which essentially means when it will be equal to 1.0, then loop will not execute anymore. Down below, there is a check to verify that the x is actually being equal to 1.0, and those two lines are for storing the values for the reference. You might think that there is nothing special about this code, and it will execute and stop when the x reaches 1.0. But essentially, it's an infinite loop. And it is because of that how the floating point number data type is constructed. Let's open the data block as a reference, and let's start the PLC. The FB test float is called directly in OB1. It will execute as soon as we start the PLC. Okay, we can see that PLC is in stop mode. An error has occurred because we have defined the array from 0 to 100 of real, and with the iterations we have gone over that. But even though if we would remove this part of the code, the PLC would eventually go to the stop and report an infinite loop in the diagnostic buffer. Our loop has made more iterations than we would expect it was intended to. We can see that at 10th iteration, the value is equal to 1.0. So in this case, the test bit should be actually set to true, which is not the case. And similarly, we can see that more of the values are being stored, which means that the loop is executing further. And why is it happening? Here I have found a cool web page where it's being explained how the floating point numbers are built. We are not going to go into details, but let's input here a 0.1, and let's see actually the value being stored in a float. And we can see that it's not exactly 0.1. And with every iteration, the error is going to be increased. That's why the condition that x in our case is equal to 1.0 is never happening. I would like to show you a similar example in Python, as we can use the floating point data type there as well. And there we can also see the higher accuracy, which I couldn't find the way to show it in the TIA portal. Let's have a look at the similar example in Python. I have declared x as a 0.0 and create a loop. When x is not equal to 1, then increment it by 0.1. And we can see that there are a lot of results. I had to stop it manually from executing. Let's try again, but let's limit the amount of results so we can actually see the exact values. So it will print out the x values only when it's lower than 2.0. And now we can see that the value for 1 is actually 1.09999. Thank you for your attention. I hope that you have liked the video. I would like to ask you for a small favor. If you would have a second, could you please fill out the survey, link in the comments? And as a thank you, I will share with you an OPC UA cheat sheet with the Python code, how to read and write specific data types and some other useful things. Thank you and see you next time.